Ongoing advances in software permit the integration of architectural and engineering workflows to extend the traditional functionality of BIM applications. As a result, architects and engineers can virtually collaborate to optimize both architectural form and engineering function while changes are still easy and before any expensive procurement and construction begins. Consider the layout of a heating, ventilation, and air conditioning system, or HVAC for short. It would be easy if the first design of the HVAC system functioned efficiently without any modifications. However, and in reality, initial designs for complicated systems like HVAC do not always function as initially intended, especially if architectural changes are made. A better approach is to conduct virtual trial and error tests. In doing so, engineers can flexibly test designs early and thus minimize project risk. Spatial's 3D Interop suite of translators enables a critical first step in the collaboration between architects and engineers by importing various BIM formats ranging from standards like IFC to commercial formats such as DXF or DWG and packages like Revit. For example, BIM applications enabled by 3D Interop can quickly import complex IFC models of office buildings with many stories, each story containing various structural elements as well as electrical and mechanical systems like HVAC. In addition, 3D Interop now enables the activation of filters to only import specific information in an IFC file. For example, applications can now filter IFC models for specific stories and structural elements, as well as associated data for electrical, water, fire suppression, and HVAC systems. Architectural elements and some HVAC components on the third story of the office building are shown after import by 3D Interop. With the option of upstream filtering in 3D Interop, architects and engineers can more efficiently leverage specific information in complex models. Such flexibility greatly enhances the productivity of applications, especially for large projects with many levels of embedded data. To design an HVAC system for a building, an engineer must add relevant components like ducts, vents, blowers, pipes, pumps, and heat exchangers to the architectural model. A BIM application can quickly employ both 3D Interop and CGM Modeler to design an HVAC system for the third floor. In this example, 3D Interop has already imported some HVAC components and architectural elements. Now CGM Modeler can be used to automatically integrate additional HVAC components into the third story, such as inlet and outlet ducts. This process includes not only creating ducts, but also cutting access holes into existing walls. After creating inlet and outlet duct models with cutouts between walls, the HVAC design for the third story is ready. Consider a hot summer day. Will the newly designed HVAC system cool rooms to comfortable temperatures for employees while also conserving energy costs? To answer this question, the engineer can conduct computational fluid dynamics analysis to determine the temperatures and airflow in specific rooms with the HVAC system turned on. The first step in conducting a CFD analysis within a BIM application requires meshing of rooms enabled by 3D Precise Mesh. The engineer begins by meshing the internal volumes of rooms. The meshes can include structural elements like walls, windows, doors, and specific components like ducts, vents, pipes, and radiators, as well as furniture and office equipment for more detailed analysis. The process of creating volume meshes from room geometry can be a challenge, especially if details such as components and furniture are considered. However, 3D Precise Mesh enables robust and high-quality meshing capabilities that make this task easier. 3D Precise Mesh automatically creates surface meshes that respect the internal surfaces of rooms depending on detail, simpler for structural elements to more complex for components, office equipment, and furniture. From the surface meshes, 3D Precise Mesh then creates volume meshes of the room's interiors. This two-step process is more robust than just creating a single volume mesh. Note that 3D Precise Mesh enables associativity between the meshes and underlying geometry. Therefore, the application can automatically incorporate any design changes made to the architectural model or to the HVAC system into the meshes. As a result, architects and engineers can quickly consider architectural changes without manually updating meshes each time. Now the engineer is ready to virtually determine if the initial design of the HVAC system can efficiently handle a hot day. A CFD solver is embedded in the BIM application to calculate temperatures and airflows within rooms at different times. The engineer can analyze the results to determine if any modifications to the HVAC system or room's architectural configurations are necessary. Thanks to associativity between the meshes and underlying geometry, if any design changes to the architectural model or HVAC system are made, the meshes can be automatically updated and a new simulation conducted quickly. After one or more such design iterations, an optimal layout for an HVAC system can be achieved early in a building's design cycle. 3D Interop, CGM Modeler, and 3D Precise Mesh enable multi-role teams of architects and engineers to collaboratively work and conduct virtual trial and error tests of designs when design changes are relatively easy, thereby saving project time and ultimately costs. Visit our website today to see how Spatial extends the capability of BIM applications to enable collaborative workflows among architects and engineers.